Last time we discussed about the ionic bond, and we have seen the different characteristics of ionic bond, how it forms, and what are the types of the ionic bonds are there. Today we're going to talk about the same covalent bond. Yes, the chemical bond that we last time we discussed, it was almost three types that we are having in our syllabus. First is ionic bond, second is covalent, and third is coordinate bond. Now we're going to discuss about the covalent bond in very detail. We're going to understand what is covalent bond and what are the characteristics of the covalent bond, what are the conditions for the covalent bond, for the formation of the covalent bond are there, and also we're going to understand what are the types of the covalent bonds are there. Now, first of all, we need to understand the word co, the valent and bond. Just break down the word over here. You're seeing this covalent. The covalent word, co means together or the two together, we say. And valent means is related with the valency. It is related with the valency and the bond we know, where something, two elements are getting attached to each other. That is what you bond, we say. Or in a general sense, where the people get attached together with a certain relationship that we have in our society. Okay, so let's move this one. We're gonna understand the chemistry, not the society. Okay, so covalent bond, and what is basically this term is signifying means together. The bond is forming due to the valency. If you remember the last time we discussed about uh, when two elements are coming together, one is metal, another is non-metal. One is electropositive, another is electronegative. So electropositive was trying to give the electron, electronegative trying to take the electron. But what will happen if the two elements comes together and both want electron? They don't want to give the electron, but they both want to have an electron. What will happen in this case? Well, in this case, only one solution is there, that they have to share the electron. This is the same thing has been done in the covalent bond. Understand this one. Suppose two elements are coming together. Which electronegative element you know? Now, first of all, you need to understand this one. Electronegative series. What is the electronegative series? There's a mnemonic. I have created a mnemonic to remember this one. Is phone, call, Britain, international, school. Okay, so remember this one. This side electronegativity is decreasing, means what? The tendency to gain the electron by the element is decreasing. Now, see this one. Phone, call, Britain, international, school. Fluorine, oxygen, nitrogen, fluorine, bromine, iodine, sulfur, carbon, hydrogen. So which element in this series is having the least electronegative characteristics? This hydrogen. And the most is fluorine, then oxygen. Okay, we're gonna take the help of this series in the later when we're gonna discuss about the types of covalent bond. But just for kind of information, understand the idea. When two elements are there and they both are electronegative, means both having the tendency to gain electron. So what will happen in this case? They're both gonna share. Just take a very simple example of water. What is the formula of water? H2O. This is the covalent bond that we know. It is the most common thing that we have the idea about. So water is over here, H2O. How it is forming? First of all, we need to understand what kind of elements it is made up of. Oxygen and hydrogen. So oxygen, the last shell, how many electrons it will have? 6 electrons. Okay. And hydrogen is having how many electrons on last shell? One electron. So this hydrogen needed to complete one because the first shell, K shell, needed only 2 electrons to complete. This hydrogen only requires 1 electron, but it is electronegative. It wants to have an electron. This one is also electronegative, wants to have an electron, but the chlorine is so much electronegative. You can see over here. It also wants to have an electron. Then there is only one possible way. They all came together and decided, okay, look, you want, I want. Why don't we share this electron? So they decided to share the electron. The hydrogen said, okay, I'll share. This hydrogen said, I'll share. This is mine. This hydrogen is mine. Sorry, this electron is mine. And this hydrogen saying this electron is mine. But at the same time, oxygen said, your both electrons is mine. And now what will happen? Oxygen was having the 6 electron, 1, 2, 3, 4, 5, 6, plus 2 added becomes 8. Now, when the last shell is completed, that means it is chemically stable. Now, it will not react any further. Now, see this one, hydrogen, 1, 1, 2, completed, 2, completed. And in this way, the water molecule forms, we represent as like this. You're seeing this bond? This type of line, it is generally represented by this kind of line. So first of all, the covalent bond, what is the covalent bond? We're gonna have a little bit idea about it. The covalent bond, when two elements come together and they share the electron, what kind of electron? A pair of electron. And what kind of element? Electronegative element. Always remember, when metal and non-metal is coming together, they will not form, they will never form a covalent bond. They will form ionic bond. But if two non-metals are coming together, if two electronegative elements are coming together, they will form covalent bond. Okay. So what will happen? First of all, the element must be electronegative. They will share pairs of electron. Now, they cannot share only one electron. One electron they are sharing and they are sharing. No, it will never happen. Always two electron take the participation. Always at least two electron take the participation in the formation of covalent bond. So what will happen in this case? See this? Here, two pairs of electron is being shared by oxygen and hydrogen in a different way. This one and this one. Okay, now. So it is represented by the line. This line we represent, like we are representing hydrogen, oxygen, then hydrogen. You're seeing this. So this is the representation. Whenever you're seeing this line, just get the idea. Here it's 2 electron is being shared by the two elements. If it is 3, that means 6 electron. If it is 4 or 2, that means 4 electrons are there. We will discuss this later. Okay. And this one last point is, it is because of the weak electrostatic force we sometimes call van der Waals force. Okay. So let's just take another example to explain all those things about. And we will also discuss how the definition should be, what way we can define this covalent bond. Okay. So you're seeing this nitrogen and hydrogen, two elements are there. Nitrogen having 7 atomic number, this is having the 14 atomic number. What will gonna happen over here? See, nitrogen is electronic configuration, it has been shown over here. 2 electrons on the first shell, 5 electrons on the last shell. Means what? If it is 5, how much it needed? 3. And hydrogen came, this hydrogen said, oh, nitrogen, I need just 1 electron. Could you arrange something for me? And nitrogen said, no. Okay, you will say, yes, I can arrange for you, but you need to call 2 hydrogen more. So what did the hydrogen say? It did. Call the 2 hydrogen more. 2 hydrogen also came into to take the participation in chemical bonding, that is a covalent bonding. Okay. So what will happen? Here you can see nitrogen at the last shell, 5 electrons has been there, and the hydrogen. 1 electrons are there. Now nitrogen needed how much? 3 more electrons, and each hydrogen is having 1 electron at the last shell. But hydrogen also needed 1 electron. So each hydrogen done what? Took the nitrogen electron. This hydrogen took the nitrogen electron. This hydrogen took the nitrogen electron. Now each hydrogen completed 2, 2, 2. But nitrogen not yet taken. It will take again this whole. So you can see 5 electrons was there, and each electron of each hydrogen has been shared by the nitrogen. Now nitrogen is completed their octet, and each electron is completed by the octet. Now you see nitrogen and hydrogen, 1 electron has been shared, so we'll represent by 1 bond. This will represent by 1 bond, and this will represent by 1 bond. So each pair of electrons has been shared, signified by, or just depicted by a line. That means a pair of electron has been shared. This one, this one, this one. 3 electrons you're seeing. Okay. So 3 bond you're seeing. That means the 6 electrons are in the participation. So always remember one thing. that whenever we're talking about the covalent bond, there the electron will not go and somebody will take, but they always be in share. Means this hydrogen have the authority over this electron, same as this nitrogen is having, or this hydrogen is having the authority over this electron, same as this nitrogen is having. Means what? Means the both are having the equal sharing property. That's why they are gaining the whole octet state. So idea, I think, pretty much clear. Now you see NH3, H is there, 3 and 1 nitrogen is there. This is the ammonia. So this is the structure of the ammonia. We can discuss about the lots of things, like you can write down the structure of methane, which is CH4. Okay, this is the carbon and hydrogens are there. Okay, and you can also draw the structure of CCl4. Okay, there's many examples are there, but you should do this too by yourself. Okay, and it is also already given in the notes, so you can go and look at there. And if you'll find any problem, then you have the way to contact us. So please do contact us if you're finding any difficulties. We are always here to help you out whenever you're finding any problem. Okay, so move back. Last one, which is a very important to understand, why it is weak van der Waals force. If you remember the ionic bond, the bond was created between Na or Cl. There was a plus and minus. It was complete. Sodium was always positive ion, and it was complete negative ion. And there is an electrostatic force of attraction. But here is what happening. We are not seeing any charges. So what kind of bond is coming together? Actually, it is. See, very simple example I'm showing you. Very simple example. Okay. See this very simple example. The example of HCl, hydrogen chloride. Now you can see hydrogen is basically non-metal and chlorine is also non-metal, and they share the bond. We call it covalent bond. Many times the question comes on the student think, oh, hydrogen actually belongs to the group 1 element and the chlorine belongs to the group 17. That means a metallic group, non-metallic group coming together, they form the ionic bond. No. Hydrogen though belongs to the metallic group, but it is not metal. It is non-metal because it stays in the gaseous state in normal condition and it has no conducting property of electricity. Okay. So what is happening? Hydrogen and chlorine is coming together. See in this case, hydrogen is here, chlorine is here. Okay. So what will happen in this case? We can understand the idea. Hydrogen is having 1 electron in the last shell and chlorine is having 7 electron in the last shell. Okay. So what will happen? This hydrogen will share simply and this chlorine will share simply. 8. Chlorine will obtain the 8 and the hydrogen will obtain 2. Done. But we know that electron never stay in the rest condition that you're seeing over here over the board. Okay, they never will stay in the rest condition. They always revolve around the element. So what will happen? This electron will started revolving around the hydrogen, but always remember, it will not only revolve around the hydrogen, but will go and revolve around the chlorine like this. Like this. And this chlorine atom not always revolve around the chlorine, but it will revolve around the hydrogen as well, like this. So what will happen? This electron, while going towards this, suppose it is over here. Now the hydrogen, chlorine, hydrogen electron is at the chlorine, revolving at the chlorine side. Okay, so what will happen? This, if the electron is detaching, that means it will gain the positive. It will gain the positive, means electron will detach, element becomes positive. So it is going far away from hydrogen and revolving around the chlorine, it will become positive suddenly. And if the electron is going over there, it will become negative at the same time. Now, positive, negative attract each other. That is what the electrostatic force. But what will happen after some time? This electron will again come to the hydrogen side. The hydrogen electron again come to the hydrogen side, but this chlorine electron will go to the hydrogen side. This chlorine again gone to the hydrogen side again. And what will happen? Two electrons came. That means becomes the negative charge and it will acquire the positive. Now you see the sign has been changing. The charge's polarity has been changing, but it was continuously changing. Sometimes hydrogen becoming positive, chlorine becoming negative, attracting each other. Then hydrogen become negative, chlorine become positive, attracting each other. But the sign has been changing continuously. And it is not permanent like NaCl, which is the sodium is permanent positive, chlorine is permanent negative. No. Here it is has been changing. That's why not a constant force generate, but the force direction changes always. So in this case, what happened? A weak electrostatic force generated. That is what creates a covalent bond. So you can understand the idea why the ionic bond was greater than the covalent bond, because it was generating between the two permanent ions. But here, the force is generated due to the van der Waals force, the force that acts between the two elements if they are sharing the electrons. And the electrons properties are always they revolve around the element. Okay. So this is the basic idea. It is not necessary for you to understand in a very deep, just for the simple identification if the question is popping up, how it is creating force. Just sharing the electron, the force will create, because we know in order to create a bond, we need a force. So this is how the force formed. Okay, that is not, you don't need to go into the very deep if you're not understanding. Just rewind the lecture and understand it again. Okay, but it's a very simple idea over here, and it is not necessary to understand. The first three things is very important for the covalent bond. Now, I think you had a idea about the covalent bond. Let's just recapitulate it. Covalent bond. Now, what is the covalent bond? When two elements comes together and share a pairs of electron, or the single pair of electron, or the many pairs of electron, that doesn't matter. They form covalent bond. Like if you take the example of oxygen, take the example of oxygen. Take the example of oxygen. Two oxygen is coming together. Two oxygen coming together. Okay. Each one of them is having how much electron? 6 electron in the last shell. So what will happen? This oxygen will take 2 electrons and this oxygen will take 2 electrons. And then it will sharing 2 pairs of electron. That means 4 electron has been shared. So we can write like this. We can write like this. So the idea is very simple over here about the covalent bond. The definition of the covalent bond could be written in many different ways, but the best way to say, when two elements come together and they share one pair or more pair of electrons, then the bond is created is known as covalent bond, and it is between the two electronegative element. That means between two non-metals. So always remember, if the question is asking in your exam, so what kind of bond forms between the two non-metals? We can say covalent bond. What kind of bond forms between the metal and non-metal? That is the ionic bond. Okay, and sharing a pair shares a pairs of electrons, and it is represented by the dash. So the oxygen has been represented by the dash. So you're seeing this 2 dashes over here. That means the 4 electron has been shared in this process. Okay, the idea is very clear, I think. In the next lecture, we're going to discuss about the types of the covalent bond and how we can understand that what are the criteria that gives the formation of covalent bond. And we will also learn the properties of covalent bond. Thank you so much.